Good evening, everyone, and good morning to Sebastian and Glenn. We welcome you to this webinar, and I hope everyone is doing okay and staying safe. So, on behalf of All India Oracle Users Group, who I think you've heard of us by now a lot of times, we are a platform where we provide. We're a platform where we try to provide a platform for technical professionals, Oracle users to network, share, interact, and grow and learn from each other. So usually during our non-pandemic our usual mode, what do you call this? Modus operandi would be we would meet up every other month or every month across various local chapters, conduct events. But due to pandemic, we are mostly focusing on webinars. And now, over the past few months, we've had focused webinars where we've had an entire series on performance tuning a month. We focused on rack a month, and now database upgrades and migrations the previous month. And now we're focusing on maximum availability architecture. So I hope you're enjoying these webinar series, and I'll continue further. So as I was talking about, these are a list of prolific speakers that we have lined up for this entire month. You've already heard from Marcus and Anil, and we've got, as well as Ian, and we've got Glenn over here today, Sebastian as well, who's here to help out with the question and answers. And then you can see the list of speakers that we do have coming up. So it's going to be a really exciting month, and we're really looking forward to learn more from these experts. A few housekeeping rules. As you know, please use the Q&A panel at the bottom of your screen for all your questions. If you need any help from us, use the chat box and we will be around to help you. Again, as I was mentioning, please use Twitter to continue this conversation. Say you revisit this presentation a day later, a week later, you discuss it with your colleagues, and you can think of more questions. You've got more ideas around things. We encourage you to reach out to our speakers over Twitter, have a conversation, and learn as we grow. We get a lot of questions about accessibility of the presentation that would be available on the AIOG website. And after the presentation completes, give us a day or two to upload it. So as soon as the webinar is done, give us a day or two, and you will find the presentation material over there. Again, as I mentioned earlier, we've got what we believe is an absolute best lineup of maximum availability architecture experts that we could find for you. And we would really appreciate any feedback over Telegram, Twitter, or you can send us an email if you've got any topics in your mind that you want us to engage in. So with that, I'll move on to the topic for today. Today, we are really excited to have Glenn, who's a Senior Director of Product Management at Oracle. Glenn leads and manages Oracle MAA, or Maximum Availability Architecture Solutions and Best Practices, as well as the team which is responsible for product management and strategy at Oracle for Active Data Guard, Flashback, fleet patching and provisioning, online operations, and edition-based redefinition as a part of the database organization. Along with Glenn, we also have Sebastian present, who is a consulting member of the technical staff with Glenn's team, that is the Maximum Availability Architecture Product Management team. So he's again responsible for database high availability DR architecture, and he's been working in Germany for 10 plus years before he joined the MAA team. And again, we've got lots of experts over here. We hope, I'm really excited to hear from Glenn and the team. So I hope all of you enjoy as well. And you have questions for Glenn, just think about it, digest it, and hope Glenn enjoys as well. With that, I would like to extend a really warm welcome to Glenn. Glenn, could you kindly share your screen?
Thank you. Let me go ahead and share.
Thank you. We can see your screen now.
All right. Everything look all right?
Yes, it does.
All right. So welcome everyone. Yeah, I'm definitely excited to be here. You know, it's been a long year, and I think everybody's excited. We're back at AI OUG again. So today, as I said, I'm going to go ahead and jump into Data Guard and Active Data Guard. As part of the MAA series, we're going through a lot of different parts of our solution overall that kind of come together as part of our maximum availability architecture blueprints here at Oracle that we recommend you use. So today we'll be diving directly into Data Guard and Active Data Guard. And I say 21C here, but I'm going to touch on the overall features. It'll be kind of a mixture of overview for those less familiar with Data Guard and Active Data Guard, and then we're going to dive in particular with the 21C features. We're going to go in a bit deeper and talk about the features, as well as some best practices around some of the existing features that you know and love, as well as some of the new features that we've gone ahead and rolled out. So my name is Glenn Hawkins. I run product management for Data Guard as well as maximum availability architecture. And you'll be getting the deck later, so you'll have my Twitter handle and all those type of things. So I'll touch on kind of the business continuity and the importance of having a business continuity plan, and then we'll jump into the other items. I won't go here through the agenda. I just kind of spoke to them. But one important thing is that you ask questions throughout it. I think you're used to that in the other sessions. Go ahead and type them in, and Sebastian Solbeck will be responding as I go ahead and present. So don't hesitate to go ahead and shoot your questions our way, and I'll try to leave some time at the end as well to go ahead and respond to some. All right, so as far as kind of business continuity as a whole, as far as kind of the criticality of business continuity, it's really become even more intense, I think, with the whole pandemic and everything we've had. Businesses are living and breathing virtually these days. And so the risk to the business is even more so. And this is true to a lot of customers that we go ahead and we talk to on a daily basis. They've really felt it acutely that any type of downtime or any type of, even from a maintenance perspective, can have a huge impact. But unplanned downtime obviously has the most impact. And, you know, financial risk, customer risk, and regulatory, right, depending on which industry you're in, are all kind of aspects that can impact you. Some are very short-term, some can be long-term, some can be even more acute if they happen on a regular basis. If you have downtime followed by additional downtime, unexpected, and multiple outages, this can become even more severe, right, with each one of those outages. Now, as far as kind of the way we go ahead and handle this, just to go ahead and cover the terminology piece, and those of you heard us speak at Oracle quite a bit, we usually talk from the perspective of recovery time objective, or RTO, and recovery point objective, or RPO. These are measurements of downtime and data loss. So downtime from basically the type of the event, right there you can see in the middle, it's the seconds, minutes, hours, hopefully not days and weeks, of downtime that happened since the actual outage occurs, and the data loss is how much data you maybe have permanently lost because of the outage if your primary system is unavailable and unrecoverable. So these are two very important pieces. Depends on your business, depends on the type of application. And usually, you know, the applications, all your applications in your environment have different objectives from an RTO and RPO perspective. Not each application is created equally on that front. In addition to that, we define high availability and disaster recovery separately. So high availability protects us from localized failures. You know, you have a cluster, one of those systems go out, you want to be able to go ahead and continue your application and minimize any type of downtime, or hopefully eliminate it completely. So you keep your high availability up. It'll prevent any type of system in the case of planned downtime or an unexpected outage. Disaster recovery is more from a entire site failure. Your data center goes down, large power outage, some type of natural disaster takes place. You need to have site redundancy and be able to fail over, ideally in an abstract fashion that wouldn't impact the application. But once again, it depends on the RTO and RPO objectives that you're going in to try to reach, which a lot of times change as your application has been around for a while, as you get input from users, as they experience any type of downtime, maybe planned maintenance, and you get complaints that it's taking too long. These things evolve over time. So since we're talking Data Guard today and Active Data Guard, the focus really is on the disaster recovery piece, right? It's protecting from that site failure, providing that site redundancy. So let's talk Active Data Guard, well, Data Guard and Active Data Guard and MAA. The first thing I think to be aware of, and all of you, I think, at least most of you probably are familiar with, Data Guard has been very, very central to our business for a long time. It's a critical piece to the database. We focus a lot of investment in it. And you've noticed not only do we do it on the on-premises product, our core product, but we make improvements on Exadata, specific for Exadata, with our engineered systems, as well as in the cloud. All our different cloud platforms, Data Guard is a major focus, with Autonomous Data Guard coming out last year, or is it maybe we're almost 2 years now, with the pandemic going on. I lose track sometimes. For that being out, right? So we've gone ahead and created all that automation around it. But the bottom line is it's one of our most features that we invest the most in here at Oracle. We do a ton of testing associated with it to go ahead and pull it, because it's a disaster recovery solution. So essentially we're going ahead and ensuring it goes in and fulfills its purpose. So since 11.2 here, you can see some of the features, some very, very popular ones that you guys know and love, like fasting, for example, our Mira feature that went ahead and provide the parallel redo apply, all the way out to 21C now, which we've gone ahead and rolled out in the cloud, some of these features, and you've seen kind of the evolution of those. Usually the way it works is we go ahead and invest in the standard kind of on-premise core product, and then the features are later exposed in our cloud offerings, right? Or maybe you don't even see them because they're underneath the covers, right? With all the automation that we have in Autonomous Database and so forth. So I'll be talking through these. I'm going to focus most of this on 19C, as I really want most of you guys, if you haven't moved to 9C, we're hoping that you are, as that are our last terminal release. And then I'll talk to 21C and some of the new features that are out and how those will be evolving as we move forward. Before I do so, it's good to see how a Data Guard fits into the larger picture, and what we're talking about when we talk about all these different MAA tiers, which is what this series is about. So, they evolved. I have a whole session on this later, so I'm not going to go in deep. But essentially, from customer insights for the last 20 years, we developed reference architectures. Those map to different RTO and RPO values and are shown here in our different metal tiers: bronze, silver, gold, and platinum. Many of you are probably familiar with it. Those encompass a bunch of different features associated with continuous availability, data protection, active replication, and scale out. You see some sampling of some of the features, including Active Data Guard here. Some of them overlap across multiple, right? Like Active Data Guard would fall into active replication, as well as data protection, as well as continuous availability. And then we have our different deployment choices, everything from our kind of our generic systems to Exadata to the cloud platforms, where we're building more of this automation. We're doing more of it for you. The important part with MAA to know is it's not just a set of features. Once in a while I hear people go, well, gold is just rack and Active Data Guard. Well, yes, from a feature perspective, it's made up, and we include these features and recommendations. But also the configuration and operational best practices that go along with those. And those are reflected in, historically, we've had them in different technical papers that we have up on the MAA site. Those more recently have been moved into documentation to make it easier for us to go ahead and evolve them faster and for you guys to navigate them. So those are important to go ahead and take a look at. You just go ahead and search for Oracle MAA, click on database, you will find all those links, all those best practices. Those different tiers fit different applications. These are just examples: dev, test, prod. A lot of times your lower critical prod might be bronze. Silver, we're starting to get more serious. Usually rack is in there. We're talking about high availability. And then disaster recovery starts to show up in gold and platinum. And this is where Active Data Guard and Data Guard make their appearance as a critical piece to this. It's where we have our site redundancy. So it's where we go ahead and start talking about replication. We start talking about disaster recovery, and we work our way from basically downtime of minutes and seconds to zero downtime with our platinum architecture, which encapsulates both Active Data Guard as well as Golden Gate. Now, the way that we go ahead and do this, and the one thing that the MAA team, this is a focus team of almost 40 individuals, veterans of the company, and have been with the company, most of them with the company for 20 plus years. They use a technique called chaos engineering to essentially proactively break things. So the MAA team's job is to go ahead and ensure that our systems are the most reliable. So they're constantly going ahead and breaking things, which is even more important in an HA and DR to ensure that when you break things or when one part of your disaster recovery might not work, you make sure that another one goes ahead and works. So we have kind of redundancy built in. So some of the examples are network failures, data corruption. Literally, these guys are pulling power cords out of walls, shutting off systems, breaking the Exadata machine and ways to go ahead and ensure that things go ahead and can fail over properly. So chaos engineering is a technique, and the team, we have some of the best experts at chaos engineering in the country as part of the MAA team, going ahead and testing the system resilience. Not only are they testing MAA, but they're also testing our products, and they're in charge of system testing for the cloud. They're one of the teams that go ahead and test that. So Data Guard, I'm not going to spend a lot of time on this. I think a lot of you are familiar with Data Guard. Maybe you're less familiar with Data Guard versus Active Data Guard, but I'm going to go through the basics here, just for those that may be less familiar with it and why it's a unique part of disaster recovery and a lot different than other types of replication that you see out there. First of all, you get it as part of Database Enterprise Edition, and it essentially provides you with a kind of an active-passive approach to the default Data Guard. Now, we're not talking Active Data Guard yet. Its main job is replication to go ahead and keep the standby site in sync with the primary. We're doing also continuous validation. This is a very, very important part of Data Guard, is that we're going ahead and we're testing and validating those blocks as they come over as redo. Now, Data Guard is mostly known for disaster recovery, but it also is used for migrations and upgrades as well. And we even have the DBMS rolling feature in it, which uses the transient logical standby. I'll talk about it a little bit later, that we have in there. We have a link. I have a link to some demos that you can find. These are all on the Data Guard page. You can go ahead and take a look at those as well. So this is kind of the core of the technology. I'm going to go through it in a little more detail here in a moment. So if our site goes out, so the entire rack cluster goes down for whatever reason, maybe it's a power outage, we go ahead and shift all those users over to standby. They would experience some downtime. In this case, Data Guard is not going ahead and bringing over the in-flight transactions would not automatically be replayed as part of Data Guard. However, as we go ahead and make the same transition in Active Data Guard, we're going ahead and have a few more features associated with that. First of all, we have the active, and this is what Active Data Guard is known for, and the name applies, right? Your standby can now be used, and you can go not just read-only, but in 19C, read mostly workload can be moved over to the standby. So we added DML Redirect to go ahead and allow you to do the occasional update. We're not talking about two primaries here. You will impact the performance of the standby if you put a large load against it. We're talking about a smaller load with about maybe 5 to 10% of that load to be the occasional update associated with it. So that's what Active Data Guard is known for. But the reason it's a critical part of MAA is not because of the active feature and the ability to offload. It's because of the next few features, the automatic block repair, which allows us to bidirectionally go ahead and repair blocks, and application continuity, which replays transactions. So I'll talk about both in a little more detail. But those are the kind of two core features that provide better data protection, and why Active Data Guard is recommended over Data Guard as part of MAA. We also have features like the FarSync feature, which provides zero data loss across any distance. And this is kind of an important piece of the next part of our discussion as we go ahead and look at it. So we move the users over. The big piece is that it's with the app continuity piece, we're not only going ahead and the committed transactions are obviously already there with Data Guard as well, but now the in-flight transactions with application continuity will also be replayed. And essentially that role transition from the application client perspective will be a brownout. There won't be a lockout associated with it if you have application continuity configured. Now, Data Guard has 3 different protection modes and some variations of there. FastSync is one of those, FarSync is another one that provide different protection. And these tie into your RPO and your RTO values, right? What you're going ahead and looking for from there. And you can choose essentially maximum protection, maximum availability, and maximum performance. Basically, maximum performance at the bottom there is our solution for applications that maybe the two sites are farther apart. There's some network latency between them. And the way async works is it's going to go ahead and not wait for the acknowledgement on the other side. It's just going to go ahead and kind of fire and forget over to the standby. The other two, maximum protection and maximum availability, are going to go ahead and ensure, well, maximum protection is going to ensure zero data loss associated with that, and maximum availability is going to do its best to, right? It's going to wait until it's going to go ahead and try to go ahead and wait for a confirmation, that acknowledgement. If it doesn't get it past a certain time threshold, then it'll go ahead and resume. The idea is a mixture of performance versus protection. So as we go ahead and kind of take a look at these guys, looking at the synchronous as well. This is our maximum protection mode. It's going to go ahead and provide the most protection. It's also the way max availability will work. But we're talking about synchronous replication here, where we want to ensure that every single transaction is in the primary or in the standby with an acknowledgement before we go ahead and commit it to the primary database. So a commit comes in, they go ahead and make it so way over. We can see the RFS is going to go ahead and receive the redo. It's going to write it to the log file, and then it's going to go ahead and send the acknowledgement back. At that point, you get a commit to the primary. Now, if that round trip takes a long time, you're obviously going to have some performance hit on the primary database. That's why if there's a large distance, if you have a lot of network latency between your primary and your standby, it can be difficult to go ahead and do this. A lot of times, we recommend having one standby database in the same data center or a nearby data center very close with a very low network latency under 1 millisecond between them near the primary, and you set that one up for synchronous. And you also have a remote standby that's protected from a site outage that you have out there that's going to go ahead and take advantage of one of these other solutions. We'll start with fast sync actually, or other version of it. And then we'll talk about kind of the asynchronous approach. So fast sync's another version of sync, but slightly different. It does open you up to a very, very low chance of data loss. And the reason it does that is because what it's going to go ahead and do is the idea is for literally us to not have to wait for the acknowledgement for the write to the standby redo log files. Instead, the second the RFS goes and receives the redo, it's going to send the acknowledgement back. So it's going to go ahead and send it back. The transactions will be committed in the primary database. Obviously, this means that the round trip will be much faster, and thus your performance will be less likely to be impacted on the primary database, even over some distance. What it does mean is if both the primary and the standby went down basically simultaneously for whatever reason, you would be open to a slight amount of data loss from when that standby redo log, since it hadn't been written to the standby redo logs yet. Now, from a farther remote standby system, we almost always use the async. I almost always see use. Now we do have the far sync ability as well, which I'll talk about later. So this is a very common. We see a lot of our customers. They don't want to risk any performance to the primary database. The standbys maybe hundreds of miles, maybe even 1,000 miles away. Hopefully they have a local standby as well to protect from kind of immediate outages that may happen, but depends on your data center configuration. But the idea here, as I mentioned, is kind of a fire and forget situation. So it's going to go ahead, the commit comes in, so right the primary, it's going to go ahead and transmit it, but the commit will go ahead and the commit acknowledgement will happen instantaneously on the primary. So you don't have any performance hit associated with this architecture. But as the data takes some time to make it over, so you may, in transport and the apply, there's a chance to go ahead and see some impact as far as the overall performance there. And we measure all this. You can look at the performance of your redo transport, your redo apply, and kind of get a measurement of this and how much RPO you perhaps open you up to, which is probably very small, but there is some gap in there usually associated with that. So that, in a very, very quick nutshell, is how Data Guard and Active Data Guard kind of work under the covers. That's how the different protection modes work associated with them. So I'm going to switch gears here, and we're going to go ahead, and now that we have the fundamentals, for those that may not have been aware of those, we're going to talk about some of the specific features. and some of the very important features that basically supplement what we just talked about. Because all the capabilities we talked about with all that redo, are really talking about the committed transactions, as we talked about with the acknowledgement, the round trip, and the redo. But what about those in-flight transactions? And I told you that those can be protected as well. Well, the missing link here, and we're constantly asked about this, that, well, we have this outage, but we still see some impact of the application. And worse, because of the way our applications work, sometimes we have to start rebooting the application servers and all these type of things. App continuity can protect you from that by abstracting all that from the application. Essentially, you don't have to make any changes to your application. Essentially, this feature works. It's mostly in the Oracle database, but you have to use the correct driver and the correct connection string. We support a bunch of different technologies, Java, obviously quite popular with Oracle products, but also .NET, Python, Node.js. And we have an application checklist that you can go through that'll go ahead and walk you through the way this works. There's some difference between application continuity and transparent application continuity, which was made available in 19C. But the biggest is, for those familiar with the way connection pools work, we don't require a connection pool with what we call TAC, transparent application continuity. But in some ways, the application continuity is more flexible, so we still provide support for both. But this is a critical feature. It works with both RAC and Active Data Guard. So you may have heard Anil talk about it for those who attended our RAC session, and Marcus, they went ahead and talked about application continuity as well. It's in both products. It's represented in both. The whole idea is that it replays transactions in a seamless way, so the application clients essentially see a performance blip. This can go ahead and resolve. Not only is it great for the application and the end users, but it also means your application developers no longer have to deal with the situation of handling those errors coming back into the application. So they usually have to code for all that, those failures. We take care of it for you with application continuity. So you don't have to do that. It's a load off your application developers. It's one of the most problematic areas of app development, going and handling this type of error handling if transactions fail and trying to replay them, or worse, letting them go up to their end users and having them see errors and having to go ahead and redo their transactions. So I also mentioned DML Redirect. So the DML on Active Data Guard, one of the main features of Active Data Guard we talked about was read-only. Now, we've been saying you can move your read-only workload for a long time now as part of Active Data Guard. However, a lot of applications that were going ahead and trying to move their workload over to the standby did have a need to do the occasional insert or update. Let's say a reporting application that was trying to do some type of tracking on who was running reports, which reports were run. Those are just some simple examples of where you might want to do some inserts and updates. So what we did is we introduced DML Redirect, and we've actually optimized it. In 21C, the performance of it has even gone ahead and been optimized even further. But what it does, as you can see in the diagram here, the DML comes in on the standby and essentially makes a round trip out to the primary. So this goes ahead and ensures that we're not compromising ACID. We keep our, as far as our transactions, valid. However, it allows us to go ahead and have that occasional insert or update to go ahead and supplement those applications. People were creating database links and all kinds of things, trying to work around this problem before, and we really wanted to simplify it for you. So we introduced this. So 19C, we actually improved 21C, the amount of inserts and updates you can go ahead and kind of push to the standby. Before, our rule of thumb was about 5% or 10%. Really depends on the application of how many inserts or updates, how many of those the DML can be a measurement, the percentage of the load on the standby before you start impacting the performance of the standby, because that's where the performance impact routinely is if you get that that DML workload any higher. So we've gone ahead and improved it in 21C. So I'll probably be doing a blog post on that fairly soon. There's already one out there for 19C, going ahead and making that 5 to 10% recommendation. You'll find that in our MAA blog. But we'll be going ahead and putting a new one out with our new analysis that we're running to provide some more best practices around that. And you'll probably be able to go ahead and kick that workload up a little bit higher. I won't give you a percentage quite yet until we go ahead and run all the numbers. Another thing that we went ahead and did was Flashback. A lot of people surprisingly don't know about this, but Flashback, is everybody uses it, right? It's our rewind button, and it's really incredible on the Oracle database in that we not only can do it at the database level, but we can do it at the table level. We can do it at the transaction level. We do it at level. So you have a lot more flexibility in logical flashback as well as a physical flashback to go ahead and rewind things. It's fantastic if a mistake like this happens where someone does a logical error and accidentally goes ahead and gave everybody promotion to VP, which could be funny, but maybe has security implications, right? If that table is used for security purposes, all of a sudden people have a lot more access. This could be a huge problem, particularly for a public company. So you'd want to have it rolled out back very quickly. Now going ahead and doing a restore may be a lot of effort. It'd be a lot easier to go ahead and just rewind that one table, and that's what Flashback provides. And then we have the idea of restoration point and guaranteed restoration points. A lot of people like to go ahead and use guaranteed restoration points during maintenance events. But historically, what you had to do was go ahead and take this Flashback technology. You had to go ahead and apply these on the standby as well, manually. So you create your restoration point on your primary, then you create it on your standby as well. We automatically propagate that now with 19C. So all of those configurations that you have a standby that you're using Flashback with, where you manually had to do this, which was problematic, sometimes error prone, open yourself up to problems, we take care of this for you now with 19C. This lowers your overall maintenance of using the Flashback feature significantly. And it's one of the reasons, if you're using both of those technologies, which a lot of people are, why you want to get up to 19C very quickly, go ahead and do this. So we propagate those restoration points along. Also operations, reset logs, and those type of things are also propagated across as well. 19C, we also went ahead and fast start failover is one of the features we always recommend with MAA. If you want a very low RTO, you have to use fast start failover. So you get an observer out there as well as going in and watching this, and the observer as well as the primary, the standby keeps track of the primary. So we have multiple going ahead and tracking and monitoring the system to go ahead and ensure that we're going ahead and failing over in the case of an unexpected outage. However, a lot of people are fearful of a false positive, right, where you go ahead and fail over, maybe you didn't have to. So what we've been going ahead and doing is building quite a few knobs in the fast start failover to give you that assurance, to provide you with the ability to test the feature, as well as going ahead and tune it and have lots of different toggles associated with it. So we've been adding more and more knobs to it to make your life easier. Of course, there's defaults that we recommend on those. But this is one of those features to allow you to test it a lot easier in your environments, to give you that peace of mind. So you can go into observer only mode, not go ahead and kick over and actually kick over the failover. You can test it in observer mode only to go ahead and test your configuration. So that's one of the main features. And mostly we're talking about kind of the core Data Guard now. I'm going to talk about some Data Guard broker features here in a moment as well. Now, in 21C, now, I didn't want to get too far along before I bring up kind of our marquee feature for 21C. So Data Guard, by default, in a multi-tenant environment, is configured at the CDB, at the container level, meaning all the PDBs in there, you have one single configuration. It handles all the PDBs in there, and it fails over everything at once. Very easy from a configuration standpoint and from going ahead and setting it up. However, we get a lot of people that ask for PDB level. Can I get that PDB level granularity? Now, keep in mind, though, that most failures really happen at the CDB level, right? So most failover situations, it's much less frequent for a single PDB to become sick or non-performance or to need a failover event. Usually, any type of failover that would be going on, or even a switchover, those switchovers for a single PDB make a lot more sense and happen more frequently. But in the failover situation, it's less frequent. However, we wanted to go ahead and support this as we have a lot of people that have gone and requested it. In addition, it's a key feature that we want to go ahead and provide in our cloud offering too. So it's something that we're working on from that perspective. And so we rolled out this Data Guard for multi-tenant, or DGPDB. Now, this feature is not currently in the cloud right now, the version of 21C. It's rolling out with the on-premise version that we're going to be rolling out. So it's right around the corner coming out as part of that. And the idea is to go ahead and be able to provide that. So you can configure a single PDB. So we have our sales, we have our HR sitting here in Boston. We want to head and just want to fail over the HR. We can now go ahead and do that with this feature to go ahead and provide that failover. So it sounds simple, but for those that are aware kind of the way and our configuration and the way we go ahead and work with it, you can understand from a multi-tenant perspective, this is one of those features that we wanted to get right We wanted to ensure we did it. We want to ensure we did it perfectly. And this is part of a disaster recovery solution. So it required a lot of chaos engineering to ensure that, we're going ahead and we're maintaining our disaster recovery. Now, with that in mind, I wanted to go ahead and kind of talk about when you may want to use one versus the other and how the current features go ahead and line up, because it's not apples to apples with what you're getting at the PDB level, the CDB. First of all, you choose one or the other. You can't have both. For obvious reasons, it's happening one or the other. And one of the big things that you have to think about is the configuration. So if you're doing it at the container level, you only have to configure it one time for all the PDBs. But with the PDB level, you're configuring per PDB. So there's more effort associated with the configuration. But now the trade-off is you have more control now, right, per PDB, and you have that ability to fail over one versus the other, right, which our second bullet point implies here. Integration with RMAN, of course, is there. But we start seeing some major differences on the next bullet point, right, on the protection modes. And we just talked about sync versus async, max protection mode, max performance mode. Not all the protection modes are available in our PDB. We only have max performance mode. Only our asynchronous replication is there. Also, we don't have fast start failover. So the PDB configuration, while it's gone ahead and is testing, we're working with MAA, it does not meet all of our RTO requirements for our gold tier targets, right? So because without the fast start failover, it's not quite there yet. Now that is, I will tell you, that's our highest priority feature moving forward as far as going ahead and rolling them out. Now, but as I mentioned, we wanted to get this feature right. We want to ensure the core of this feature worked as well as possible and was heavily tested before we rolled it out. So purposefully, we've gone ahead and rolling these out in phases. So you're not going to see all these features jump into the next releases. These are going to come out over time. We're going to go ahead and roll them out and roll these features, with fast start failover being incredibly important as well as a few of these others. But the offloading feature, basically a lot of the active data guard features are not available in the PDB. They're there in the CDB. If you want all those active data guard features, you're offloading data. The automatic block repair, app continuity is critical to you, or you're doing upgrades with DBMS rolling, you want to go ahead and stick with the CDB configuration. All of this is planned. It's coming for the PDB as well, and you'll see it coming in subsequent releases. Things with OEM support, a lot of you guys using Oracle Enterprise Manager Cloud Control out there. So that support is coming now. You can go ahead and monitor and manage today through DGMGRL. It's there. It works. So everything's still there through the broker. You can go ahead and take advantage of it. The OEM support will be coming soon as well. We're working very closely with our Enterprise Manager counterparts to go ahead and roll out full support for the PDB configuration. Not only from a monitoring perspective, which a lot of it is there for multi-tenant already, but also from a configuration standpoint. So, but you'll be able to use the broker today to go ahead and configure all this out. So this is DGPDB. You'll hear us go ahead. We call it Data Guard for multi-tenant, or just DGPDB for short, to go ahead and encapsulate these features. So this is really the biggest 21C feature. It's not our only 21C feature though. We have a lot of things that we've gone ahead and done that build on what we've done. It's kind of a mixture of enhancements and sticking with the theme of going ahead and making the product, as far as going ahead and making our active data guard features even more performant, which is what this feature. And then as far as going ahead and adding more knobs. The other thing is to go ahead and make configuration and changes more easy. And I'll talk about that in a moment as well. So we have these themes to go ahead and enhance basically the usability of the product, the performance of the product, like this feature, and then as far as the ability, more knobs on it. This is kind of our themes associated with it, along with the multi-tenant feature I mentioned. So what we had before, if you guys were looking at 19C, we had this database buffer cache was preserved. This is a feature that basically ensures the performance on the standby during a role transition. So you have all this workload, the primary just failed, or you're doing a switchover, and it's going to go ahead and forward to the standby. Now the standby is going ahead and already handling read-only workload and an active data guard configuration. Now it's going to go ahead and get all this write load as well and get quite a bit more workload on it in the first place. We were also blowing away though the buffer cache and the result cache on the standby, which was impacting performance of those reporting database that were going ahead, or reporting applications that were utilizing it. So what we wanted to go ahead is preserve that. In 19C, we preserved the database buffer cache, and now with 21C, we're preserving the result cache as well to go ahead and ensure their performance. So this is a performance improvement on the active standby database. Now, I also mentioned that we have a bunch of features where we've gone ahead and made the product easier to handle. One of those was that we got some complaints that the Data Guard broker compliance wasn't quite standardized. The directory structure wasn't easy to follow. It wasn't simple. You guys wanted it clean and more organized, and so we went ahead and delivered that. You know, this is one of those features that seem kind of small, but will impact literally everybody on a day-to-day basis that's going ahead and using the Data Guard broker client. So all the subfolders are there. We have an environment variable, DG admin that's gone ahead and set up. Everything's very organized and clean now to associate with the Data Guard broker. So the change in 21C. We went ahead and also rolled out the ability to create FARSync instances. Now, I didn't talk a lot about FARSync, but FARSync is the ability to go ahead. We have a FARSync instance that can be set up there, and the idea is to provide synchronous replication over long distances. If you don't have a local standby, this in particular comes in handy that you can set up a FARSync instance nearby, do synchronous replication of the FARSync instance, and the FARSync instance handles asynchronous replication out to the remote standby. You still have to think about where you put that FARSync instance, and the Data Guard broker's job is to help you with that, to go ahead and create it, to monitor it, and configure it. And now we've gone ahead and we've created that kind of that full circle, that full life cycle for that FARSync instance, which has no database files. It's just literally the control files and the redo. So you can't fail over the FARSync instance. You can go ahead and it's kind of handling as a proxy to go ahead and handle that and providing that extra layer of protection. Placing the FARSync instance is tricky though. It's very similar to where you put a local standby. You want it isolated and very nearby as a synchronous replication, but you want it. You want to ensure that protection as well as you're not putting it too far away from there, so you're introducing too much latency. I should point out that everything I'm talking about here is also represented with best practices in our new Data Guard. If you guys search for Data Guard MAA best practices or just Data Guard best practices, you'll find all our new documentation. Literally every single feature I'm talking about, from new features to these 19C features, we have best practices associated with them. We have a whole section on FARSync associated with it. Lots of different use cases, including reader farms and so forth, you can utilize with it. So the next one to talk about is fast start failover configuration validation, and this falls under the theme of more knobs. We're giving you more control over fast start failover. In particular, we want to go ahead and ensure that you know, we're not doing any type of false positive associated with that. So go ahead and set it up. So you have a threshold associated with it as far as doing it. We also have validation checks, which is what we're talking about here. We talked about the observer-only mode that was introduced in 19C. Now this one is a validation. We do the validation for you for the entire fast start failover. This includes the pre and post callout scripts, which is also a new 21C feature with fast start failover, because we know that sometimes you need to go ahead and do additional callouts associated with that. We not only provide support for those callouts, but we validate them as part of this fast start failover validation. So you can see the theme here. We're allowing you to go ahead and test things. We're allowing you to become more confident with your fast start failover configuration with observer only mode in 19C and this coming in 21C. And we're allowing more knobs on that feature. The reason is we want you guys to go ahead and utilize that, as that's how you get to the RTO values and minimize that downtime down to seconds associated with it, which is critical. Stole my own thunder on this one. This is the call out feature, which I just mentioned in the other one. So we have this obviously as part of 21C as well, so you can incorporate those into your fast start failover. Now here's one of our knobs. So how much lag allowance we go ahead and allow in max availability mode. So max availability mode, and I didn't talk about it a ton when we talked about the protection modes, but essentially what it does is it stays synchronous up to some type of allowance, right, before you hit some type of timeout associated with it, and then it will go ahead and commit the transactions, basically jump into kind of max performance mode associated with that. Now this feature is a little bit different. It allows you to go ahead and define how much I want to go ahead and allow that lag allowance. You know, what is my level that I'm willing to accept from a lag perspective, and still basically go ahead and do a fast start failover, right? Basically, if the lag allowance is too high, if my standby has fallen too far behind my primary do I still want to automatically fail over to the standby? Or would I rather go ahead and handle that from a manual perspective? This new fast start failover lag limit allows you to go ahead and define that. All right, so I managed to make my goal, which is rare for me, and stay within my kind of 45 minutes because I want to leave some time to go ahead and answer some questions. I'm sure you've been going ahead and asking them already to Sebastian, and he's been answering them. But before I do, just to go ahead and kind of finish up with as far as the way Data Guard kind of works. So Data Guard, one thing I did mention is how it differs from a standard storage replication. You probably already got that in the diagrams, but everything's happening in memory, right? It's happening out of SGA as far as our memory goes. So it's basically doing a mem copy, and it's only sending the redo over. This is really important because what it really means is you're isolated, you're protected from all those type of things that may be happening on disk. If you're using storage replication, let's say someone deletes a file on the disk that kills your entire database. Somehow they get into root access, they delete something right from the disk. In a storage replication standpoint, that would be copied over to the standby environment, meaning you just corrupted the standby environment as well. So storage replication is a fantastic solution for the upper stack. It fully makes sense. But for the database, and we started out with this, we started with customers using storage replication, and we created Data Guard specifically to combat the fact that people were, we were leaving too much rope for people to hang themselves, and they were being hung. People were running into problems, and we still see it all the time with anybody using storage replication. And you'll find almost every other database solution on the market is using storage replication to go ahead and do it, or just replicating the container at the VM level. And you're basically hoping for the best at that point. And there's a very decent chance that whatever just killed your primary is going to kill your standby too, and you may not know it until you try to fail over. So Data Guard protecting you from that. That's one critical piece, and one of the main reasons it differs. We have a whole new technical paper on this that we rolled out, which goes ahead and talks about how Data Guard is different from storage, remote mirroring, storage replication. We had that paper for a while. We just updated it more recently, and you can check it out on the Data Guard website. So please do. It's a great paper. Not very long. I think it's only 10 pages, so you can get through it. It's not one of our 40-page papers, so it's worth a read. Now you have all that validation built in as well. So we're validating constantly against corruption, and we're also going ahead and doing the automatic block repair. So if we detect a corrupt block, it will go ahead and copy over from the standby over to the primary to repair it automatically with Active Data Guard. Active Data Guard does this. And by the way, it's bidirectional. So it would happen from the primary to the standby as well. If there's a block that's corrupt on the standby, it will copy it over from there. And if you have more than one standby, you have even more protection associated with automatic block repair. All this just shows up in your alert log, and that's it. It's just a blip in the alert log, and you're protected from it. And I will tell you that block corruption, when it occurs, a lot of times, sometimes it's tied to hardware problems. It's not very frequent, but it is catastrophic when it occurs. So having that data protection is a critical piece to it. Automatic block repair is just one. Sometimes it's not what Active Data Guard is most known for, but it is one of the most important MAA features, along with app continuity. So we have all these features, all these different protection modes to go ahead and provide you with the ability to cross-regional replication or local protection as well. It integrates with RAC and everything else, all our other features, multi-tenants we've talked about. We've created a ton of optimizations with Exadata, and all of those, of course, have fed up into Exadata Cloud Service and our Exadata Cloud Customer that you can take advantage of. Keep in mind that Autonomous Database is also built on top of Exadata, so it's getting all those benefits that we've gone ahead and done. For those looking for those benefits, we have an Exadata MAA, whole pilot, a whole bunch of different papers, a whole bunch of presentations on it, where you can go ahead and delve into all the benefits that we provide and how the hardware side of Exadata supplements everything we do at the software level with MAA, and how all that's reflected in our cloud services as well, all the way up to Autonomous Data Guard, which is literally, depending on which autonomous database you're using, shared or dedicated, is literally, I think shared is 2 clicks to enable it. It'll stand up your standby site, set it up. If it needs to reconfigure with, it takes care of everything kind of behind the covers. Dedicated is more flexible, and you can set up cross-regional, and it's basically you have access to all the active data guard features, which you don't have with shared. We don't have the ability to go ahead and offload read-only workload and automatic block repair. A lot of those features are not there, kind of similar to what we saw kind of versus DGPDB versus our container level configuration. A similar feature kind of balance there. But dedicated has all the different features associated with it that you can go ahead and set up. Some of them need to be configured manual. And if you look at our cloud MA presentations, which Sebastian Solbach is on here, had a lot to go ahead and do with putting that on there, along with Ludovico on my team. Caldera, you guys might know that in the ACE community. Those features, that we go through all those in detail and the way it goes ahead and works and exactly what's automated, what's manual. And this is constantly evolving as we're adding more automation to our cloud all the time. But Autonomous Data Guard is kind of the fruition of us doing everything for you from a configuration and our management standpoint. Has everything built in under the covers. So whether you're using the product for disaster recovery or migration or a mix thereof, you know, we get a lot of hybrid configurations as well these days. So our multi-cloud configurations, I just went ahead and put out a, you see a blog series and a video will soon be available on demand with Megaport, one of our partners, talking about multi-cloud configurations. If your database is sitting in the Oracle cloud, but maybe the rest of your stack is sitting in another cloud, very popular these days. We also support that, and we're rolling out a bunch of new collateral associated with that configuration as well. So with that, I will go ahead and stop and take a look. We can take a look at some questions and answers. Go ahead up there. So do we have any ones that we think should be covered in live as well? I'm also going ahead and kind of bringing up the list. It looks like I've been answering quite a few already.
So let me check the ones which I already answered. If there is one, there are two on there which I'm not sure on. Maybe you can look at them. The first one is prepare database for Data Guard with the command itself as options. Will this work for both CDB and PDB levels? So with the new 21C feature for the PDB failover, does this command prepare database work with that or not? So that's the first question.
Actually, it does not right now in 21C. It's something that we're going ahead and rolling out for in a subsequent release. Realistically, that though should be available in probably in the lifespan of 21C actually, as we go ahead and roll that out. And there is a chance it will roll out with a patch release before you guys even see the product. So I will say it is coming very, very soon, but not quite there yet.
And the second question would be, how often is there any way how to identify the DML redirection frequency that should be used to not impact the production database? I have in mind that there were some numbers about maximum 5% or something, but I'm not sure. So maybe you know better than me, Glenn.
Yeah, so we've done a lot of testing on this. As I mentioned, you know, I have a blog post on this that we went ahead and we rolled out. It basically talks about the frequency, and I mentioned 5 to 10%. Now, the 5 to 10% is not your overall workload. Once in a while, people hear 5 to 10%, and they go, "Hey, I can move 5 to 10% of my primary DML over to the standby," and that's not what you want to do. We're talking about 5 to 10% of the overall workload on the standby could be represented as you know, insert or updates DML. Now that is just kind of a rule of thumb, and you really need to go ahead and test it for your application. What you're looking for basically is impact to redo apply. So look at your redo apply lag. As far as going in and you're monitoring that, you can monitor that with Enterprise Manager, or maybe you can go ahead and you're going out for our broker to get those numbers. But that's where you want to go ahead and look at potential impact to the performance. And the way that surfaces for the application is if you get too high of a DML redirect workload, it will basically impact the performance of our standby. Now, in 21C, we boosted the performance of this significantly, and I do not have an exact measurement of that, as I said before. It will be higher than 5 to 10%. We made some really incredible improvements as far as the impact that DML redirect causes on the standby. So if you just keep your eyes peeled for a blog post on that. I hope to get it out in the next month on that exact subject.
The second question where I was not 100% sure of, there was a question in regards to a potential problem when you essentially have when the archiver kicks in to do the gap resolution. Sometimes you have the issue that on the primary, that archive log might already have been backed up, so not available anymore. Is there any integration with RMAN to automatically recover that archive log to be able to ship it to the standby? I said no, but maybe I'm missing something.
No, not yet. Not yet. You know, it's interesting because we had a discussion on this. This is something that we are looking into, but the answer is no, not quite yet. We don't have that level of backup configuration with RMAN, not today. Okay, do we have more questions? We have 4 minutes left. I know it's really late in the evening for you guys. Thank you for hanging in there with us.
Yeah, thank you, Glenn, for a detailed session on Data Guard, Active Data Guard, and I think definitely we learned something today. And also, guys, Glenn is actually meeting us again on 25th August. Please mark your calendars. He's going to talk about maximum availability architecture, best practices, blueprints for every deployment platform. It's a very important session. I know this is not the right time for our community between before going to sleep, but also we need to thank them because it's too early for them, especially the speakers, and it is not easy these days working from home, family, kids, and you can imagine the atmosphere, right? And also, I don't know how many of you know, 8 a.m., especially the US time, is very, very key slot, and most of the speakers are actually 4 times or 5 times booked. So they are giving us that slot to us, our community. So we really need to thank every speaker. And thanks again, Glenn, and we'll see you again on 25th. Where is my mouse? Sorry. So guys, please connect us in Telegram if you need any quick information. Also, we keep posting what's coming. We remind you. So please connect in Telegram. We really hate sending emails, but the best platform is Telegram. So what's coming up, right? So it's also important. The rest of the session is really key. That's why the whole design is planned by Anil and Marcus. And I think we need to really thank, by the way. So before closing this session, we really need to thank Anil Nair as well as Marcus for designing this whole summit, right? So please join us on Friday, 13th of August. Ricardo is going to talk about Oracle zero downtime migration and best practices, and he's also going to show you the live demo, right? So with that, Anil, you want to do any closing comments, or Glenn or Sebastian before closing?
I just want to thank all you guys. It was a great session, great questions. And I really look forward to the MAA session on the 25th.
Super, thanks a lot. And yeah, so please keep all your burning questions ready. So you can look at the topic, look at the abstract, and keep all questions ready so you can copy paste, and speakers are ready to help us, right? So with that, thanks a lot. Good night for most of the participants, and have a nice day for speakers. With that, we are closing today's session. Bye.
Bye. Thank you.
Bye.
Thanks, everyone.